Show by the principle of mathematical induction that for all n belonging to the set of natural numbers n, the expression n raised to the power of 5 divided by 5 plus n cube over 3 plus 7n over 15 is an integer. Okay, let us begin. Now here, we don't have to show here. First, we need to understand the problem. We're not being asked to prove that this expression is an integer. It is already an integer. All we have to do is, by using the principle of mathematical induction, we need to show that this is a statement and it is going to be true for any natural number that we pick up. So to do this, what we'll do first, we're going to consider a statement p of n. So let p of n be the statement. So here we have p of n such that we have n raised to the power of 5 whole divided by 5 added to n cubed whole divided by 3 added to 7 times n over 15. This expression is an integer. So here we have converted our statement into a mathematical statement which is denoted by p of n, and let's label this as statement number 1. Now, in order to verify that this is a true statement, first what we'll do, we will check if it is true for the first natural number 1 or not. So for n equals to 1, what do we have? We see that p of 1 such that we have 1 over 5. All we're doing is replacing the n value with 1. 1 over 5 added to 1 over 3 added to 7 over 15. Now when we add all of these, all three of this fraction, we're going to get the value 1. And we know 1 is clearly an integer, which means that our statement p of n is true for n equals to 1. This implies that our statement, original statement p of n, that this is going to be a true statement for n equals to 1. Or in other words, we can say here that our statement p of n is a true statement for the first natural number. However, we need to show that it's true for other natural numbers as well. Now, instead of plugging in the next natural number 2, 3, 4 and the rest of the terms, that was going to be a very lengthy process. Instead, what we'll do, we're going to generalize this problem. So what we'll do, first we will suppose that let for some natural number m, for let m belonging to the set of natural number, let us suppose that p of m is true. P of m is true for some natural number. We're considering some natural number m, or we can say for some m belonging to the set of natural numbers. Now in essence, what we are saying here, that p of m, the statement is such that we have m raised to the power of 5 divided by 5 added to m cubed divided by 3 added to 7 times m over 15. Now this expression is an integer. So we're considering some natural number m and we're rewriting the original statement p of n in terms of p of m. So let's label this number 2, and we are considering that this statement is a true statement. Now using this statement, we'll have to show, using statement number 2, we'll have to verify, or consider, we have to show that the statement p of m plus 1 is also true. P of m plus 1 is also true, where m plus 1 is simply the term that is consecutive to that of m, so the term that comes after m. That means we have to show here that the statement p of m plus 1 such that we have m plus 1 whole raised to the power of 5 over 5 added to m plus 1 whole cubed divided by 3 added to 7 times m plus 1 whole divided by 15. We have to show that this expression is also an integer, and we have to show it by taking the help of statement number 2. So this is our goal. So how shall we do that? Now what we'll do, let's take the help of statement number 2. So from statement number 2, since we have already considered that p of m is a true statement, now here what we can do, we can suppose that let's say m raised to the power of 5 whole divided by 5 added to m cubed divided by 3 added to 7m over 15. So here we're saying that since this entire expression is an integer, what we can do, we can represent it in terms of an integer lambda, where lambda is simply a integer. Now we'll be taking the help of this to prove statement number. So this is going to be a statement number 3. So now we will be taking statement number 3. Now let's take statement number 3, m plus 1 whole raised to the power of 5 divided by 5. Added to, we have m plus 1 whole cube divided by 3. Added to, 7 times m plus 1 whole divided by 15. So in the next step, what we'll do, we're going to expand m plus 1 whole raised to the power of 5. Now there is a trivial exercise which I'm leaving as an exercise for you to try out. And similarly, we'll be expanding m plus 1 whole cube as well. So now that we have expanded, we're going to take some common term. So we're going to consider the first term of each of the expanded expression. So we have m raised to the power of 5 over 5. To it, we are going to add the first term of the expansion of the second term. So here we have m cubed over 3. Added to, we have the second last term, which is 7 over 15 whole multiplied to m. Fine. This is going to get added to, we have 5m raised to the power of 4 over 5. So that's simply going to be m raised to the power of 4. Then we have 2 times m cubed added to 2 times m squared plus 5m over 5. So that's simply going to be m added to 1 over 5. Fine. Next, we have 1 over 3 multiplied to these 3 terms. So that's going to give us m squared plus m plus 1 over 3 added to the last term, which is 7 over 15. Okay, now this expression can be replaced with lambda. We have already assumed that is lambda. Then we can combine m raised to the power of 4 plus we have 2 times m cubed added to, so 2m squared plus m squared, that's going to be 3m squared. Added to, so m added to m, that's going to be 2m. Added to 1 over 5, added to 1 over 3, added to 7 over 15, that's simply 1. Now, m, that's a natural number. 1 is a natural number, lambda is an integer. So sum of all this term is going to be some integer. We don't have to worry about the value, but we know that it's definitely going to be an integer. So we have successfully showed that this expression is indeed an integer. That means we are saying here that the statement p of m plus 1, that is a true statement. This is true. If this is true, then we can generalize and finally say that the original statement p of n by the principle of mathematical induction is going to be also true for all values of n belonging to the set of natural number. That means any natural number that we pick, the statement p of n is going to be true, where p of n is given by this statement n raised to the power 5 over 5 plus n cube over 3 plus 7 over 15 is an integer.